At long last, I finally have proper dust collection in my shop. This video is sponsored by Oneida, the maker of the dust collection system I decided to buy last fall. I did a ton of research before deciding on one of their systems, and I reached out to them to see if they'd be interested in providing the Ductwork as sponsor of this video, and well, here we are. This will actually be a two-part series. In this first part, we'll go over the Ductwork design service Oneida provides as a complimentary service when you buy one of their dust collectors. I'll show you how that whole process works, how the design service consultation goes, and ultimately what the resulting dust collection game plan looks like once complete. The second video will be where I roll up my sleeves and build the system from the plan that my design consultant at Oneida and her team came up with. That video is going to take a few more weeks to put together with all the footage I accumulated during the install, so be sure to subscribe so you don't miss it. With that all out of the way, let's walk through designing my system. Ductwork layout is crucial to a good dust collection system. Putting unnecessary bends or hard turns in your layout can drastically reduce the suction of your dust collector. Thankfully, you don't need to be a ductwork design expert, as Oneida provides a ductwork design service for free when you buy one of their collectors or the ductwork they recommend. Getting started is as easy as downloading their form and describing and loosely drawing out what you've got going on in your shop. These details include things like how big your shop is, how tall the ceilings are, how much room you have for the collector, what types of obstacles you might need to work around, etc. For me, the obstacles I would need to work around include my lighting, which is flush mounted to the ceiling, the laser exhaust, which goes up my east wall, my ductless mini split head, and the big one, the garage door of my two-car garage shop, which happens to open up over top of my table saw and router table. No biggie. The next step of the form asks you to list out all the tools you have in your shop, how many dust ports they have, and what size those ports are. As you can see, I had a few unknowns on my form. For example, at the time I started my consult, I didn't yet have a lathe, but I knew I'd be getting one very soon, and thus I needed my ductwork design plan to account for this. I basically put TBD on any line where I wasn't sure how big of a port I needed, or whether I needed a port at that location at all, such as at the drill press. These were areas we'd focus a bit more of our conversation on once we got to the phone call part of the design service consult. The last part of the form is where you get to be a bit artistic and break out your pens and pencils and sketch out a basic layout of your shop from a bird's eye perspective. Oneida does not expect this to be 100% to scale or perfect, as you can see by their example drawing. It's just to help their ductwork design team get a better idea of tool placement when designing your system. I suppose the alternative would be to just measure everything out with relative distances and then describe that in text form, but that'd be a lot more work and not as easily glanceable as a drawing is. In my case, I already had a bird's eye layout of my shop to scale on my computer that I had used when planning out my shop a few years ago. So rather than reinvent the wheel and redraw it by hand, I did my annotations on top of my digital drawing and then plopped it into the form after the fact. The key things you need to include in your drawing, whether by hand or digital, are the tool names, where the dust port is on the machine, marked with an asterisk, and finally the feed direction of the wood on applicable tools, such as the table saw, router table, planer, etc. These are indicated by arrows pointing in the direction of the feed. The only other thing to include besides the dimensions you indicated previously on the form is where you plan to have the dust collector. I had earmarked the northeast corner of my shop for my dust collector years ago, when the dream of proper dust collection was just a twinkle in my shop's eye. As such, I ran a 240 volt line over there when I wired my shop a few years ago to power the dust collector I would eventually buy, my Oneida V-System 3000 that I bought last fall. With the form filled out and sent to Oneida, you'll arrange a time to have a phone consultation with one of their ductwork design specialists. I got to chat with Lisa, who has been with Oneida for over 12 years, and I really appreciate her insights. The consultation is pretty informal, but it's also collaborative, as Lisa explained.
And the goal is to kind of do a combination of things. I'll make recommendations based on what I see, what you have, and then you're going to say, oh no, Lisa, that won't work because I do this in my shop. And what we want to do is find the appropriate balance between those two things. And if you say to me, well, I want to do this, and I feel strongly that it's going to cause performance issues, we'll have that conversation, and then we'll make a decision on what's the right thing for you.
Okay.
Okay?
One of the first things we needed to decide is which orientation to mount my dust collector to the wall. I had originally started installing it on the east wall of my shop, but as I played with the various configurations of the inlet and filter arm, of which there are plenty, suiting most situations, I realized it might be better to install it on the north wall. I got Lisa's thoughts on this.
So, if you mount the wall mount on the east wall.
Yep.
So if you do that and you mounted your wall bracket directly in the corner and there's no room between the north wall and the wall brackets, the filters, if you look at your drawing that you did, you did it right. You got to see how the filter, the circle is bigger than the square or the plenum arm of the unit. If you were to swing that swing it clockwise, the brown part of the filter is going to be bumping into the wall unless you moved your wall bracket out from the north wall.
Together, we determined that the north wall would be best, and then we could move on to discussing some of the obstacles in my shop.
I think the first thing that comes to mind for me is the mini split. And so is the mini split like how far down from the ceiling or how far up from the floor? Because we have to decide is for that part of the run to start with,
Yep.
Are we going to leave it at inlet height and just come back to the wall, which is how it looks like you have it, which would put the center line of the piping at 75 inches. And so then it's like, all right, you want to get up to the ceiling to go across the room. Do we have to go up and over the mini split or down and under? Just your thoughts on that.
Lisa asked me about the mini split first and foremost, because the goal would be eventually to get the ductwork traveling across the room up to ceiling height, as to not have it any lower than needed so that I wouldn't hit ducting when maneuvering long boards around the shop. But because my mini split head was mounted so close to the ceiling, we decided to keep the height of the north wall equal to that of the height coming out of the collector, and only go up to the ceiling once that branch required it. We then got talking about my various tools and what size ports they had. One of the things that was abundantly clear to me during this part of the discussion is how collaborative Oneida is. They're not overly prescriptive in their approach. They really want to get a sense for how you use your tools and figure out the best ductwork layout for that usage. Are you saying by having it lower or higher, like I can have the lathe closer to the wall? Is that what you mean?
Well, no. So if I'm working on the lathe, usually, and it's in front of me, usually there's the motor and stuff to my left.
Yep.
Right, and then you're kind of not really all in the middle.
Yep.
So I was just trying to figure out physically, does it make more sense to do that triple drop? Because now, as I'm standing there, my drop hose is going to be more to my right with my, coming behind it, and that could be messy. So the option would be then just instead of doing the drop for the lathe on that down drop for the floor sweep, we'd stay up at the ceiling and go further down the north wall and make your drop more towards the northwest corner so that you're accessing it a little bit more over there. And again, your door is there, so I can't go too far, but I just put it to the east of the door. Against the wall.
Yeah, I kind of like that idea now that you say it. Another thing I really appreciated in my discussion with Lisa was her understanding of my shop not quite being in its final form just yet, helping me think through future expansion of my shop and the ductwork system.
It's going to be the one that comes down for the bench that we just talked about.
Yep.
You could put a Y at the ceiling, and you can size for a little bit future expansion, and you can put a cap on the end of that Y, so it's already there.
Okay.
You've sized your pipes accordingly, and then all you got to do is say, I'm now going to turn over back towards, the laser cutter, and you just put your new piping, and you've already got it stubbed, basically, for that future expansion.
One of my favorite parts of the conversation was talking through getting ductwork to my table saw and router table. What are you supposed to do when you have a garage door that needs to open, but you want to run ductwork over there too? I think a lot of people might be tempted to run the ductwork along a perpendicular wall and then jut across the floor to the tool, but that's not great in the slightest. I already kind of drag my feet when I walk, stumbling over even the slightest elevation change. I do not want to be constantly tripping over a 5 to 6 inch pipe near a bunch of tools. Going into my discussion with Lisa, I had a wild cockamamie plan for what I wanted to propose for the situation. So what I was maybe envisioning, and if this is crazy, let me know. What I was kind of envisioning is, if we're up at the ceiling at that point, maybe come back down below the height of the open garage door and then go straight down to the floor behind the router, or on the south side of the router table. Thankfully, she didn't think that was too crazy. Her only concern was making sure we didn't add more 90-degree bends than necessary to make this happen, as a single 90-degree bend can add about as much resistance to the airflow in the pipes as 5 feet of straight ducting can.
So we can do that, and what I would do is I wouldn't put extra elbows in. I would, okay, so as you've come up to this ceiling height, you're running it at ceiling, maybe you could angle it, because what we want to kind of do is prevent a lot of
90s.
elbow.
Yeah. Furthering our discussion on the table saw, Lisa asked me if I had any interest in overblade collection. I determined that I didn't, as I was worried it might get in the way with the various sleds and jigs I intend to build and regularly use with my saw. But Lisa proposed if I ever changed my mind, I could just put one of my router blast gates to double duty down the line.
What I've seen other people do is take the 2.5 off their router.
Yep.
And swing that over to the blade guard.
Yeah.
It's a little bit smaller than a 4, but it's better than a 1.5. You could maybe modify something like that.
Yeah. The last thing Lisa and I talked about was dust collection for my belt and disc sander, which is just a cheap unit at the moment, but we decided to send a 4-inch port over in that direction that I can split and modify as needed when I upgrade that tool in the future.
Maybe what I do is, instead of doing the 2 for the belt disc, because a lot of the newer ones that I'm seeing have a 4-inch port.
Okay.
I would say do a 4-inch drop with a 4-inch gate there.
Okay.
And then we can do a 4 to 2.5 reducer, because
Okay.
that's the smallest reducer. Then I make it so you'll have it. You can plug it in for the belt disc on that, do a little modification just so it fits up properly.
With that, Lisa and I wrapped up our lovely chat, and a few days later I found my ductwork plan waiting for me in my inbox, ready for review. I looked it over, and while it looked exactly like what we talked about from the top view, I was a little confused with some of the side views, and so Lisa was happy to explain on a quick follow-up phone call. As cartographers over the millennia would tell you, it's sometimes really hard to make a 2D representation of a 3D object with full clarity, and that's what we had going on here. The shop diagram's detail view for the area right next to the dust collector is where most of my confusion was, as I recalled us deciding not going directly up to the ceiling upon leaving the dust collector, but to keep it level with the dust collector's inlet. But this detail view initially seemed like that's what we were doing. It turns out that the elbows in this detail view were actually representing the 2 elbows shown here on the top view, which also explained why they were spaced a bit away from the collector and not right up to it. The first few elbows were omitted from detail A, as they would be completely horizontal in this view, and the detail views are more concerned about changes in vertical elevation. But with that explanation of the detail views out of the way, it made perfect sense and solved the mystery for me. It was nice being able to have a quick 5-minute chat with her about it, rather than going back and forth via email trying to explain that. Other than that, the only other thing worth mentioning about the detail views, and this is something Lisa explained in our initial call too, is that they show the full parts in the diagram with the lengths of the pipe you're sent for that area, not necessarily the exact amount you need for that area. For example, this section of 5-inch pipe down to the floor sweep indicates 60 inches on the diagram, but the distance from where I placed the blast gate to the floor was only 30 inches. So if I'd only used that 30 inches of 5-inch pipe in that location and had another area where I needed exactly 30 inches, I could just use the other half of that pipe without cutting into another 60-inch length of pipe to minimize waste. The benefit to this approach is that it allows you a lot of wiggle room when you're actually installing it without the need to measure every minute detail of your space ahead of time. So with that understanding of my diagram in place, we placed the official order for my ductwork, and I soon had a very optimally packed pallet of ductwork boxes delivered right to my driveway, ready for me to eagerly install, which again will be a separate video. Working with Lisa was such a treat, and she was so patient in answering all my questions and repeating herself a few times as my very visual learner brain worked to visualize what we were talking about. She made the process so easy. I hope this video gave you a good understanding of what Oneida's ductwork design service looks like and what you can expect in the process. I'll have links to Oneida's design service page linked in the description if you're interested in having them help you design your layout too. That said, I couldn't be happier to finally have my shop ducted properly, so if you want to see what it took for me to turn this pallet of parts into this working ductwork system, subscribe so you don't miss that video. With that, I'll see you in the next one, and cheers!